You make a bunch of noise out here, so they have peace and quiet in here. Because there's no better sound than the squeak-free guarantee from Advantech Subflooring and Advantech Subfloor Adhesive.
Welcome to the UnBuild It podcast. I'm Jake Bruton, and today I am joined by my usual co-host, Steve Basic.
Yo.
And Peter Yost.
10-4.
Do you want to lecture him about how that's not how that works again?
You can't fix it. Like Lexi says, you can't fix stupidity.
Normally she says that about her brother, though.
Should I be offended?
I don't know.
You'll forget.
Are you
You'll
smart
forget in a couple minutes anyway, so it doesn't really matter.
This one's off to a great start. So we have two topics today, and both of these topics are actual listener questions. I think I want to start with, we're going to start with a question from Colin. And thank you for your questions. We say this quite often, but the questions drive really great topics for us to just turn into a full episode most of the time. So it's great that you guys send in questions. Your questions are great. Questions at unbuilditpodcast.com if you want to send in a question. And just so you know, Peter does answer darn near every question quite quickly. So you do actually get a response, even though sometimes it takes upwards of 6 months for us to answer it on the podcast.
Catch up, yeah.
This one comes from Colin. I'm building a home for a client this year, and we're going back and forth on how to do the roof assembly. Jake mentions in episode 36, so that's quite the callback, that we would vent a cathedral ceiling. How would you vent a 9 and 12 cathedral ceiling in climate zone 6? Thanks for the information. P.S. Dang it, I wish I wouldn't have started with P.S. there. P.S. Hopefully the dry Steve Basic jokes never go away.
Man, it's relentless.
I had the option to not read that part, but I wasn't reading far enough ahead.
My army is growing.
Okay, so what is a cathedral ceiling for starters?
It's the upper part of a church.
Next to the parsonage.
I probably have the strongest religious background here, and I've never thought of like a cathedral ceiling. Oh, comes from a cathedral.
Don't you think that's where the name comes from?
That is scary.
Okay. So that is the shape, right? It's a vaulted ceiling in our market. That's the way I've always heard it. So most of the time in our market, it's going to end up being a scissor. It's not actually a direct vault just because of insulation requirements, so that the inside vault is at a different perspective or different angle than what the outside vault is. But that doesn't necessarily matter for the argument of whether or not we can vent it or we can't vent it.
And for the record, I call them volume ceilings. I never call it cathedral.
Yeah, because you have a degree in architecture.
Sloped or whatever. Well, it's like cathedral is I don't know what clients are talking about when they say cathedral, because I'm not sure they understand.
But when you say volume, they go, oh,
volume means, yes, we're going to press up into the attic somehow.
But would an exacting definition be that the roof structure, the insulation, and all the control layers are up at the roof structure? Is that a definition of a cathedral ceiling?
No, because you could do a scissor truss and have that stuff somewhat below. Because the scissor truss has the top chord and the bottom chord. Like, to me, when people talk about cathedralized ceilings, I'm thinking it's a 2x10, 2x12 roof. Shingles or roofing is on the outside. On the underside of the 2x10 is the drywall, insulation somewhere in between.
Maybe it's that the finished part of the assembly is not horizontal.
Well, that's why I call it volume ceiling, because it could be that you just punch up and it's a flat ceiling. It's just not at the plate height. It's 18 inches above. We've created some extended volume. in
Yeah,
there.
that's
so
true.
the types of volume sealing are like fully cathedralized, scissor truss.
So it still could be horizontal,
Could be a
but it's
coffer.
something, coffered sealing.
Yeah, interesting.
All those are volume ceilings to me.
So in his question, I'm assuming a vault because he says cathedral.
Yeah, it's probably tied directly to the roof rafters.
And there's no attic. Not even a truncated attic?
I think that's what we're assuming here.
Everything's in the rafter cavity.
Yeah.
Okay, good. Got it. Boy, I didn't think it was going to be that hard, but that's that was helpful.
Well, we are dealing with the old guy.
So how would we go about venting that? So number one of the arguments that we always have with our insulator, that every job we have to remind them, the code says you only have to vent every third bay. Like mathematically, you only have to vent every third bay. It's like 30%. That's why you don't have to do ridge vent. That's why you can get away with turtle vents. So proportionally, you could do vent chutes at the eave and every third one. Well, you can't do that when you're doing a cathedral.
I haven't read the code on this in years. I'd never read the code book.
You don't own a code book.
I do own. I own a couple because they have to, but and I even buy the commentary.
So wait, let me finish that thought though. That means you can't do that in cathedral because they're
you can't
because
they're
the
not
cavities
connected.
are isolated.
Yeah, the cavities are isolated. So.
Got it.
But if like the upper third is clear across the whole roof system, then those like turtle vents are.
So you're talking about a truncated attic?
No, I'm just saying. Yes.
Okay.
Yeah.
Or something like that. Yeah.
Okay.
Or a scissor truss or something. But like the upper third is all open air, where this bay and that bay and the subsequent bays all communicate.
Yeah.
So
that's tricky because you have both isolated volumes for part of the assembly, and then they open up into
they bleed into a
space.
pool of air.
Yeah, interesting.
Yeah.
Yep. Okay.
So you're going to have vented cavity in every single one if you want everyone to dry, and that's the whole point, is having that airflow in every single one. You have to have the calculation for, we looked at the code yesterday for climate zone 6. I don't know what the current attic insulation is. I should have brought that up.
For cathedralize, I bet you it's probably like R49-ish.
I thought it would be in the range of R49 for cathedral
I'll see if
ceiling.
I can get there while we're talking.
With some exception for,
Well, the fact that it's a cavity is why it doesn't have to be R60. Mm-hmm. Like if you did a flat, I think it's R60, but a cathedralized roof, they allow it. So the first question though is that when you were reading it, the first thing that came to mind is not how do I vent it? It's how much insulation do I want to pack into this assembly, right? Because one of the things about this assembly is how restricted it is.
Mm-hmm.
It's an R60, by the way.
Even
in climate zone
cathedralized,
6.
not for attic insulation, cathedralized.
Well, so there's
usually a footnote.
That table usually includes
a footnote. I'll look. Sorry.
Okay.
I may have spoke too soon.
It doesn't have a separate one for cathedral ceiling compared to a attic?
You guys are going to
Ceiling
get to hear
R
us be
value.
quiet. Well, it's just ceiling R value.
I'll sing
now
along.
in 2021.
Old MacDonald had a farm, E-I-E-I-O.
So
There aren't that many cathedral ceilings on farms.
Well, I'm just doing a little sing along while you guys
continue
are
your thoughts. Sorry.
Okay, so the
Interrupted.
first thing that I look at if somebody asks me that question is not how am I going to vent it, because venting it is like it's a requirement that I can solve for, and I can solve for a number of ways. But the bigger hardship is how do I pack the amount of insulation I want in there. Mm-hmm. So if it's R60, I mean, if I'm not using closed cell, I can't, or even packing rigid insulation. If I did a 2-inch airspace in 11 1/4, that leaves 9 1/4 at 7. That gets me there at 63-ish, right? Packing polyiso in there, but it's not airtight. I would be scared, and the labor is crazy on that. So when I look at it, I say a couple things. One, do I want to pack the whole cavity and push the venting outside,
So on top of the structural sheathing.
Or do I want to keep the venting below, and instead of doing 2x12s, I could frame it out of I-joists, I could frame it out of larger LVLs, or I could move to like a 16-inch parallel core truss and put that in as the rafter system. So, or I could move to a scissor truss. I mean, most of the time I'm trying to talk the homeowners into a scissor truss because it just makes economical
life
sense
easier.
and easier for everything. And you get the good building science venting out of it. But, and I'm personally, I don't like a 9 and 12. Like if the house is, or say the room is 20 feet wide, that means that
that's a big volume.
From the plate to the ridge, it's, 7.5 feet.
Yeah, that's a lot of space.
I don't know. It's ugly to me to have these steeper cathedralized. I love like a 3 or a 4 on the inside roof pitch. But so how much insulation do you want? And do I want to pack the 2x12 or do I want to move to something larger? If I move to, say, the parallel cord, the luxury I get there is I can keep the venting on the inside. I can just make the truss bigger at a slightly incremental cost, right? To go from 14 to 16 to 18 probably doesn't cost a whole lot more. If I want to stay at the 2x12, I can pack that with insulation. I can sheathe it, then go on the top, put furring strips, and put another layer of sheathing.
If you were the architect for this project, would you try to convince them that 9 and 12 is?
I would try and move to a scissor truss. That's always because it can. Most scissor trusses, from 6 down, the inside slope is about half of the outside slope. So a 6 makes a 3, a 5 makes a 2.5, 4 makes a 2. When you get above a 6, you could sheet it a little bit more in your favor. So at a 9, it's not a 4.5. You could probably get a 5.5, maybe even a 6 out of it. So you can get some pretty decent volume.
But design-wise too, like aesthetically, mounting anything to that ceiling woodwork-wise, if you have anything that's running horizontally across the ceiling, it looks funky.
Yes.
You can only do stuff that runs vertically up the ceiling, up the rake. Like, then you can't have anything that crosses.
Trying to put a fan in there, you have to drop the fan down like 6 feet to get a space for the fan blades.
Everything looks dumb mounted to that,
and
in my opinion.
If you don't have a structural ridge, you're going to have to do collar ties of some sort, right?
Yes.
Yeah.
So like
a lot of variables there.
Doesn't make much sense. Like you have to have such a large volume to have that steep of a situation. Like you have to have a resort to have a ceiling that's that.
And I think
high.
If I chose to say vent on the inside, then the question would be what kind of vent, right? Because you can go to, the big box stores and buy those cheaper, like closed cell styrofoam, but
don't get me started.
They don't work very well.
Well,
you want something that goes pretty much across the bay.
I wanted to back up to, are we telling this person, yes, you should vent from soffit to ridge a cathedral ceiling? And my attitude is, I stole this from Steve, vent until you can. And so that's the first rule, because if you don't vent this, the forgiveness is significantly reduced, and then you've got to be sure that you get everything rather perfect because there's no forgiveness in the system. And I know it's a lot more expensive to vent topside because depending upon the cladding, you're going to have to, build a funky
it is, but it
furring
isn't.
System.
I mean, so when I went up to Canada and went to Aaron's job, he had
Aaron
Jones.
Yeah. He had parallel core trusses, and he said that his building inspector made him vent on the bottom side, which I argued. I'm like, what's the difference? He goes, there isn't none, but I didn't want to put up the battle, whatever. But the point was, I asked him, like, how hard was that? He said it probably would have been easier to do it on the top side. Well, because you put the roof down. I mean, how hard is it to nail some 1x furring strips and then just put another layer of 7/16 zip?
Well, I get that's a lot of money to double sheets.
It is. It's money. I wouldn't say a lot. Listen, I've watched people put in TV. We've done houses with $60,000 worth of shade controls and another $60,000 of lighting controls.
Yeah.
So don't get me started on dumb money or that cost a lot of money, right? this is something that's going to keep the house operating for a very, very long time in a position of success.
So I want to go back to venting on the underside and using some of that depth of insulation to dedicate to venting. If you and once you vent that roof assembly, you get to use air-permeable cavity insulation for the cathedral roof. The problem is that if your insulation is air-permeable and you use vents that are not airtight, because that outside air that's moving from the soffit to the ridge, it cannot mix with the air that's floating around in your air-permeable insulation. So these companies that say that the flimsy plastic vent chutes are airtight, well, of course they're airtight until you frickin' lap them.
Yeah.
And then you have air that leaks through. And when those two mix, then you've got condensation coming out the wazoo. So my preferred method to create a airtight vent space is to put little furring strips alongside of the framing, kick down a piece of rigid insulation, and then air seal that rigid insulation.
And you're telling me putting sheathing, a second layer of sheathing, costs a lot of money? I mean, think about what you're asking.
Fair enough.
Right? Every stick has to get cut. Every piece of foam has to get cut, fitted, and installed overhead from staging.
That's not going to be cheap. I agree.
Right? Walking across that roof and having your roofer put another layer of sheathing, something they do every day,
and that would go fast.
And it would go faster.
Yeah. And you can, if you're using zip sheathing on the roof, the first layer could be cheap OSB. The second layer could be.
I think one of the biggest problems that the building industry has is we don't really do a good job in translating what it means to make a change, right? Mm-hmm. So like if I buy a car and I don't want the inline 6, I want the 8-cylinder or more power to haul a boat. It costs more money because I want better performance. If I'm a homeowner and I want to buy a cathedral-ized ceiling instead of a flat ceiling, it's not the same price. And as a builder, we need to stop trying to strive for making them the same price. It costs more money to do a cathedral-ized ceiling. That's why everybody doesn't have one, right? So do it right, charge them, and if the homeowner wants it, that's the price of a real good cathedral-ized ceiling. And stop screwing around with them and trying to figure out how do I put myself at the most risk and the house at the most risk in favor of giving the homeowner who has the big idea a cheaper price.
This is Climate Zone 6. So once we decide that we're going to create the vent space, the code says that it has to be a minimum of 1 inch deep.
Yes.
But if we go topside, we have the option of putting down not a 1x, because that'll be a 3/4 inch.
You put a piece of 5/4 down.
You could do 5/4, but I often recommend 1.5 inches because I think that's gets you even better venting. But as soon as we start to creep that up, now we've got a profile at the fascia
that's
whole
a lot
eave
taller. Changes, so we have to play around with that. But that's somewhat easily solved for because it's just geometry.
Well, and if you do a flush box or a Monopoly house with that roof, then you can play with the details.
Yeah, we've done that. I've done a dense pack cellulose cold roof in zone 6 that we vented topside.
Yeah. Okay.
I've done them before.
But I think the whole trickiness of the fascia and aesthetic height of that kind of goes away if you get to build.
The other thing that I would do
ladder frame
with zone 6 is I would recommend putting like a Myrex or something on the ceiling to slow down the amount of moisture that moves into the attic.
Well, and so let's talk about can lights and stuff like that.
One quick code point, which is when you do, let's see, does it apply if you're doing a vented? No, it doesn't. If you do unvented, then you can't use a class 1 or 2 ceiling vapor retarder. But if you vent it, you can use pretty much whatever you want for a vapor retarder.
But I had an argument with a builder, and I actually hung up on him. I think it's the only builder I've ever hung up on.
Wow.
Because I
don't know about that.
We were in upstate.
Were you guys venting your feelings or something?
Well, I was venting. But it was upstate New York, Climate Zone 5. And he wanted to put poly on the ceiling.
Ooh.
and it's a vented roof. And I told him, the homeowner's like, you don't have this in the drawings. The builder wants to put poly. Is that okay? And I'm like, hell no.
Yeah.
And the builder's like, why don't you want to put poly? I was like, it's a vented roof. He's like, yeah, I know it's a vented roof. I've been building for 30 years. We always put poly. And I said, poly's a vapor barrier. Yeah, we're trying to stop vapor. Well, if you have a vented roof, then what the hell do you care?
Yeah.
And it's climate zone 5. And Joe actually wrote a paper on it that vapor control really isn't required till zone 6, right? So that you can just have drywall up there, let the vapor go free. But zone 6, you start thinking about, do we want to slow down the amount of moisture we put into the attic, even in a vented roof assembly?
6 mil poly dies hard.
Yeah. So I sent him that, and he said, you just think you're so smart. You don't know what we do up here. I've been building for 30 years. And he started yelling at me and dropping F-bombs. And I said, listen, I didn't disrespect you in any way. I'm trying to educate you. This is the last phone call we're going to have. And I hung up. And I told the homeowner, I don't ever want to talk to, I have no need to talk to him again.
Ooh.
So
That's tough.
And he actually, they fired him, or there was something that went on. But the homeowner, we had issues with the homeowner too. But anyways, it's one of these things when you get a builder or get a homeowner that's looking for the cheapest price but wants the most expensive house on Pinterest, right? And then they're finding a builder that, yeah, the guy's a cheap price because he does the same exact thing every time and isn't willing to have a conversation.
The writing's on the wall there.
The whole scheme is positioned for failure. And I was trying to have a very calm conversation, and this guy just starts yelling at me that I don't know what I'm doing, and I've been doing this for 30 years. And that he probably didn't like it when I said, have you ever thought maybe you've been doing it wrong for 30 years?
That probably didn't go over very well.
And when you say it quietly, like not very offensive, it becomes even more offensive. So
Okay, super quick aside. I had a phone call. I was telling you guys about this the other day. I had a phone call with an architect that we work with sometimes in the Kansas City market, and he said, hey, I gave your phone number to some clients. They built a house from my plans last year. They didn't retain me during the build. They hired, they bid the house through a very respected builder in the market. They chose to not go with him. They went with another guy. They're having issues already. The house is 8 months old. I told them to call you because you could help them figure it out. And I was like, I can tell them what's wrong, but I'm not participating. Like, I'm not getting involved if they already cheaped out on somebody else. And in talking with the clients, and they have some major issues, they said, well, he was $200,000 cheaper than the other builder that the architect recommended. And I was like, $200,000 on a like $1.2 million house means I don't know what I'm doing.
yeah.
If you're $200,000 cheaper on a $1 million house, you're skipping stuff or you don't know what things cost.
Yeah, and you're just stupid because if you sit there and say, "Why is this $200,000?" I know we don't want to press too long, but I have a story. Like, this is probably the most rudest I've ever been to a client. We had a project. I had a builder, gave the client the builder's name. He priced out. It was like a whole house remodel. It was like $450,000 or something. It was a really good price at the time. This was probably like 10 years ago. Mm-hmm. And we're working through, the builder's working up the bid and finalizing everything. And then the homeowner calls me like Sunday night before we're literally weeks away from starting construction. And they're like, I think we're going to go with this other builder. And I was like, what do you mean other builder? Well, we sent the drawings to this other company. I'm like, why did you do that? Well, a friend down the street used them and it was a really good price and blah, blah, blah. So his number was like $175,000 less. And I was like, are you asking why? And I asked them, I said, they're not getting the material cheaper.
Yeah.
Like, where are they shopping?
He can't be that much more efficient.
And he's not that much more efficient.
So stealing all the materials?
Well, we go through the project. We come out. I get a phone call later on. The homeowner, because they didn't really want me to come to the job site, and I didn't really want to go to the job site with this builder.
I just remembered this story.
And So the homeowner's like, can you come and meet our lawyer and walk through the house because we're suing this builder? And like the tile fell off the wall on the steam shower, like literally all kinds. The paint job was horrendous, but I'm walking through and she's crying. And I don't know if I was cranky that day. It was probably just another day, but I looked at her and I'm like, why are you crying? She's like, I can't believe that. I said, we sat there. Where do you think the $175,000 savings is? It's right here because the guy had 2 kids come here after school to paint these rooms. That's why the paint job looks like crap.
Yeah.
Right? So don't cry. You got exactly what you asked for. Mm-hmm. Right? Go cry to your husband. So, anyways.
How'd that work out for you, Steve?
It didn't, but that's all right.
Real sympathy.
I had already gotten paid by then. I gave the lawyer my opinions and I walked away and that was it. So they figured out how to solve for it. The guy's still in business because I see his truck around and I know where he lives because I drive by it if I'm going to certain places and I always see his truck in the driveway. But anyways, things cost money.
I always tell people, like, we just had one where the clients were like, we're going to go with somebody that fits our budget better. And I called the architect and said, I just want you to make sure that, like, I'm fine with us not doing the work, but our initial ballpark was 6 to 9, and the other builder's ballpark was 4 to 6. I'm telling you, I'm not sure I can do it for 6. And the other builder saying, we'll give you everything you've ever wanted for 6. You need to make sure that you're advocating to the clients.
When you draw a Venn diagram of that, it's not.
I was like, I need you to understand that you have to advocate to the clients. It's very unlikely that they're going to get everything they want for 6, and they're either being misled or the other builder's leaving stuff out. Yeah. And you need to advocate for that. I was like, I'm not saying go in there and say, Jake needs to do this job. I'm fine with us not getting the job. I'm perfectly fine with that. I don't want these clients to get screwed over. So,
but back to venting roofs. Like, if you're going to do this, is it Colin?
Yeah.
Yeah, Colin. It costs more money to do. That's because it is more work, more building science to it, and the solutions are a little harder. That's why everybody doesn't have a cathedralized roof. In their house because of all of those reasons. So I would adhere to very strict building science principles. Yeah. If you're going to vent underneath, you really have to ask the question of how much insulation do I need to have there or how much do I want? The code, did we get anything different than 60?
Yeah, if you want to try interpreting what the code says on that one, I'll let.
All right. I'll just tell Colin he needs to read the code.
Yeah, so you can read in 1102.2.2
so it has attics. Ceilings with attics, and then the following section is ceilings without attics.
There's a square footage requirement. It's got to be a small square footage attic if you want to.
Yeah, but you can figure it out. Chances are, zone 6, you're going to want. I would say you want at least R60 anyway.
Yeah.
If anything, I'd be pressing for more like R80 in zone 6, but. Make those trusses or whatever the solution is there, get the insulation, and then if you're going to vent it, don't use the cheap vents. Either go full width on the cavity or go topside.
And the cost of venting is greater than the risk of doing unvented, in my opinion. Like you get increased durability, you lower your risk. That cost is, and not just your risk as the builder, the homeowner's risk as the long-term operation of the building.
Yeah. We have the big project that we have going on now, we have a small little room in the back. It's only, I think it's 16 feet wide. It has a scissor truss. It has all the bells and whistles. It's the wife's away room. But there we're doing a hot roof in that section just because even though we use scissor truss, it's like the top, we're at like 14 inches and it's like, it's a hassle. It's like we're going to have closed cell doing some of the band joists. It's like, let's just go up there. And it's only 14 foot long. So it's not 150 square feet of roof. But
so you're going to do an unvented cathedral scissor with closed cell spray foam.
Yeah.
Yeah. Okay. Got it.
And we still leave the vents in the soffit. So outside it all looks, and it has a ridge vent. It just isn't working because it has to line up with everything else that's out there.
We can
Okay.
bang this one out.
Yeah. So we have a question about a comment that was made in another podcast. In the podcast that we had the conversation about barn dominiums and post frame buildings, Steve mentioned that air permeable insulation requires sealing on 6 sides. Can you elaborate on this comment? Passive House Training said that air control layer could be anywhere in the assembly. Do you disagree? Working in a commercial building industry, I see that the air layer invariable being the weather-resistant barrier, except at sills, where it moves inside to catch the water. So there's kind of 2 questions there. He's kind of saying like, well, the air control layer can be anywhere, but we have to be in contact with all 6 sides of the air permeable insulation. So why you made that comment and it was kind of in passing, we kind of brushed past it. So why is it that air permeable insulation has to be captured on all 6 sides? Because we don't always do that.
No,
Right.
and
We kind of were just talking about it not being captured in attics in some cases. So why is it, Pete?
So when you go to measure the R value of air permeable insulation, you do it in a box that has a heating element on the bottom that knows how many BTUs are going in, and then there's a top of the assembly, and you can judge the R value based upon how long it takes that heat to make its way through or how much heat works its way through. That testing device, you cut the piece of, or you fill the box perfectly so that there's continuous contact of all the material to all the sides. And then when you put the lid down, it's gasketed and you crank it down. It's an airtight box. Because the only way to know the true R value, which is just the conductive resistance to conductive heat flow, is to not complicate it with convective air movement. So air permeable insulation, you will not get that R value unless you mimic those exact conditions. So when we say 6-sided containment, we're basically saying if we want to count that full R value for that, we have to assume that it's at least bound on all 6 sides.
And when you say count that, if we want that performance.
If we want that level of performance.
Yeah.
Yeah.
I had a conversation with...
Except in attics, of course.
and the reason it works in attics is just because we're dumping so much in there.
One of the reasons...
We're using it to capture itself. Right?
Yeah, you're basically saying, because it's so inexpensive to add beyond what I did for the walls in terms of R value, I do it because I can. And then in cold climates in particular, you'll get convective currents in that top layer of insulation that erodes the per inch
So it's
R
somewhat
value.
sacrificial.
It is basically sacrificial.
But it's cost effective enough and we have enough space and we can dump enough in there. But that's why wind washing at the eaves is so important to cut out.
But you'll
'cause
hear,
we don't
you'll
want
hear
it to
people
challenge.
say, oh, the code requires more insulation in the attic because heat rises. Well, heat doesn't rise, hot air rises. And so it's not because we necessarily get more heat loss through the top part of the box.
So is not that I want to challenge that, but isn't there, for some reason, I remember when you do what at Building Science, it was like energy. What was the name of the program? Coda and everybody did.
Energy gauge?
No, it wasn't Gauge.
The modeling program that they used?
but it would break down.
It wasn't moist, was it?
No. But they used it on everything that
Yeah.
like we would do, and Phil and Coda and all those guys. But when it printed out the report, it printed out where the heat loss was, like slab, foundation, above grade wall, band joist, like all of the inputs that you had to put in. And the attic was always slightly higher in heat loss than the other numbers.
So the only thing that could change that would be is if you have warmer air accumulating at the ceiling, right? So it increased the delta T from the attic temperature to there.
Which would drive a little more heat loss.
It would. So, but Oak Ridge National Lab did studies of what happens when you have a big enough delta T between the ceiling on the top floor and the temperature in the attic. And the colder it gets, the more sort of invasive convective loops you get that basically draw that draw that R value down, and you get erosion of the total.
So does that mean the code hasn't quite caught up to building science there? Because what if I did a closed cathedralized roof system? The argument would be there is no sacrificial layer, so instead of doing R60, I should be able to get away with R40 and have it the same as a flat roof at R60.
It's a really good question because
They don't.
Yeah, and the rule that we use for climate zone 5 for zeroing in on 0 is 10, 20, 40, 60 in the roof. Yeah.
So
I had a conversation with who did Achilles work for? Was it
Owens Corning?
Okay. I had a conversation with Achilles one time that he said, when you take your knife and you cut fiberglass around an outlet box and you do it poorly, and then you can stick your finger or your thumb in between the outlet box and the insulation and not touch the insulation, you've now compromised a 12-inch radius of the fiberglass. Not deleted it completely, but compromised it. Yeah. And that was like the first time where I was like, crap. Like we're just ruining
you look at
insulation right and left.
Your gun.
Infrared.
Yeah. Like it fans out radially.
Yeah. Well, so when you do that and you don't have a blower door on, you get a big blue blob. And then when you turn the blower door on, from the blob, you get these fingers reaching out. Right. So it robs you in both ways, conductive heat loss and then convective heat loss. It's a shit show around that outlet.
And the code requires that you capture it on all 6 sides. We didn't bother to look up the code language, right? It says it in the code, doesn't it?
I believe it does. It's one of the requirements for air-permeable insulation.
So there you go.
You got it.
Simple answer. So thank you for listening or watching today. If you have questions or comments of your own, questions at unbuildedpodcast.com. Do you have closing thoughts?
You guys want to hear about the new fridge I got for my wife?
A new refrigerator.
Yeah, it had really cool features, but I consider it a pretty fair trade. New refrigerator I got for my wife. It was a pretty fair trade.
She's gone.
It's bad that I got to explain the joke to you, Peter.
I think they're funnier when you have to explain them. So, on that note, have a good day.
Bye-bye.
Bye-bye.